All right, so now for the third and probably the worst of the indeterminate forms. So we're always going to start with direct substitution, right? And then when we do that, we get 0 to the right to the 0 to the right, which is 0 to the 0, which is an indeterminate form. And so now we want to use L'Hopital's rule on this, right? But the thing is, it's not a fraction, right? This is something weird. So what we're going to do here is first, it's going to help us to rewrite it as y equals limit as x approaches 0 from the right of x squared root x. And so kind of like how we did with logarithmic differentiation, if we take the ln of both sides, it's going to make this problem actually possible. And the cool thing is, due to the unique properties of limits, the ln can actually move inside of the limit and directly go with this x term thing. So then that actually lets us do some really cool stuff. Namely, it lets us bring down that square root x, right? Because if you have inside of the logarithm, the whole thing taken to the power, you can move that power down in front. So we're able to move that square root x down in front and multiply it by ln of x. And so we get ln y equals limit as x approaches 0 from the right of this, right? So now this is awesome, but we still need to get it as a fraction, right? In order to use L'Hopital's rule, we have to have a fraction. So we're going to move this square root x into the denominator. And so the way we do that is we just put it over 1 in the denominator. So now we can take the derivative. Actually, let's rewrite it first, because we can rewrite this as x to the negative 1/2, right? So now we can take the derivative of the top, the derivative of the bottom, and figure it out from there. So we're going to use L'Hopital's rule. Derivative of the top, derivative of ln x, well, that's just 1 over x. And then the derivative of x to the negative 1/2 is going to be negative 1/2 times x to the minus 3/2, because we just subtract 1 from that power and bring that negative 1/2 down, right? So now we can get rid of that negative exponent by moving it into that denominator. Two x to the 3/2, and then now remember, dividing is the same thing as multiplying by the reciprocal. So we got 1 over x, so sorry, I should say ln y equals limit as x approaches 0 from the right of 1 over x times negative 2x to the 3/2 divided by 1. So this equals negative 2x to the 3/2 divided by x. And that equals negative 2x to the 1/2, right? Because when you divide by something, you can subtract by the exponent. So that's negative 2 to the 3/2 minus 1. And then that 3/2 minus 1 just becomes 1/2, right? Which is the same thing as saying square root of x, right? So now we are saying that ln y equals the limit as x approaches 0 from the right of negative 2 square root x. And that is a problem that we can just solve with direct substitution, right? Negative 2 times the square root of 0. Well, the square root of 0 is just 0. So we get ln y equals negative 2 times 0. ln y equals 0. So now, in order to solve for y, and y is the thing that we are trying to solve for, we add a base of e to both sides. And this is going to allow this ln to cancel. And then our final answer will be y equals e to the 0. And that equals anything to the 0 is just 1. So our answer will be 1.